Learning to place objects onto flat surfaces and upright orientations. First, we have a simulation environment where the object is shown to 3 depth cameras around the scene. PRCNN then processes the images to find the required rotation. Even if the first rotation output by PRCNN is incorrect, the algorithm can compensate this by continuing to find rotation until it converges to the rotational identity. Here we have a real-life example of object placement using the iterative algorithm. The object will be shown to the Kinect V2 depth camera, and PRCNN will then calculate the required rotation for the object. After the rotation is executed, the object is shown again to the network, which outputs the rotational identity to signal that it is ready to place the object onto the shelf. One of the limitations of our approach is that the arm will appear to drop the object. This is because it is not kinematically feasible for the arm to move down any further. Here we have another real-life example of object placement using the iterative algorithm. The object will be shown to the Kinect V2 depth camera, and PRCNN calculates the required rotation for the object. The first required rotation is then completed. However, unlike the previous experiment, when the rotated object is again shown to the camera, the computed rotation is non-trivial, implying that the network has not converged to a stable orientation yet. The second rotation is then completed, and the object is once again shown to the camera. Here the network has output the rotational identity, signaling to the algorithm that it is ready to place the object onto the shelf. Here we present a failed scenario when placing the green bottle. Similar steps are completed to the previous videos. Imperfections from sim to real transfer introduce errors into the algorithm. Kinematic constraints, depth image noise, and network strain on simulated data all make the placement task harder in the real world, and are all interesting fields for future research.